my channel. So today we're going to learn about star and delta conversion, which is a very important technique that used in electrical engineering to simplify the electric circuit to solve the problems. So star and delta conversion is a technique of simplification that used to simplify the complex circuit to solve the problems, and it should be done before or prior to solving the required problem or the task. So here are the diagram of star connection and the delta connection. It not necessarily have to be a resistor, it could be anything, any sort of impedance. Okay, it could be inductor, or it could be a capacitor. So to make you understand easily, I have used a resistor. Similar concepts should be used when you replace it with capacitor or inductor. Okay, let's look at types of connection that can be formed in star connection. So this is the star connection, and on the top is one of the way to represent the star connection, and the second one is also a way of to represent a star connection. You have to remember that it could be drawn in any way, in various way, not necessarily just two methods. These are example of two ways to represent the star connection. It could be any way. You have to be flexible, and you should figure out the type of connection in that given circuit. Okay, and here is the example of representation of delta connection. Here's the typical triangle delta connection, but in terms of circuit, it not necessarily have to be a triangle. It could be in any shape. It could be in box, it could be a diamond. It depends on the way it is being sketched. Okay, be flexible so that you can adjust yourself to solve the problem. Okay, be analytical. So you should analyze the circuit before you begin to solve, or you can just rearrange the resistor across the circuit so that you can actually solve the problems. Okay, simplify the circuit first. Remember, always simplify the circuit before solving the problem, any problems. Okay, let's get to the main point, star to delta conversion. If you look here, I've drawn the diagram of star on my left hand side and the delta on my right hand side. Okay, this is the formula to derive to convert star into delta. If you look here, I have labeled R, A, B and C for star, and R1, 2 and 3 for delta. The resistance, okay, the value is not the same. Okay, so please bear in mind. So this is the formula to obtain the R1 in delta using the values in star connection resistor. Okay, if you look there, it is simple actually. It's really super simple. Just follow my steps. Okay, I can guarantee you will definitely understand. Okay, R1 equivalent to combinations of resistance in the star connection. For example, RA, RB is a pair, BC, CA, that's all. RB, BA and CB. There's only three combinations that you can form, then followed by the opposite of the R1. How to form the opposite? Let's look at it. Okay, so just now we looked at the formula, so let's derive the value for R2. Okay, so how do we going to derive for R2? It's super simple. Let's look at it. Okay, what I say on the top, at the numerator, is a combination of pairs. Okay, so that there should be three pairs in total, which is RA, RB plus RB, RC plus RA, RC, followed by, when there's R2, what's the opposite to R2? It's RA, so it should be RA. That's it. Super simple, isn't it? As I'd say. For example, let's say we are trying to figure out R3. The top part will be the same. The bottom, the denominator, will be the opposite of R3. For example, if my R3 is here, the opposite is RB. Simple as it, isn't it? So let's go to delta to star conversion. Delta to star conversion is almost the same as previous. If you look here, to find the RA, we have to use the values of delta connected resistor. So to find the RA, the top numerator will be the both sides of RA followed by each single resistor. That's all. Simple, isn't it? Let's look at the example. So RB, what I say, RB, you assume you are standing on a traffic light. You have two sides, okay? You have two lane or paths to go. So you have to look at both sides, okay? You're standing at the middle. You have two sides to go, two roads or two paths. So you're looking both sides, okay? That's the concept, simple concept, okay? So if you're standing at the middle, assume you are standing here, okay? You look at the sides. RB, you look at the sides. You have R1 and R2. That's all. R1 times R2. The bottom part, just add every single resistor around that. Add, okay? R1 plus R2 plus R3. Simple as it, isn't it? So let's look at example which gives you a better image on the concept. So this is the star to delta conversion question. So now we're going to apply the concept that we have learned before this. Just that now we're going to substitute the value unknowns with values instead, okay? So now we're going to convert the star into delta. It's the same concept, super simple, okay? Just follow my technique, okay? To find the RA, what did I say? You should look at the opposite of RA. If I would draw the RA here, the opposite would be 7 ohm. Therefore, RA, the opposite is 7 ohm. On the top is combination of pairs, addition of pairs, okay? So 4 times 8 gives you 32, 7 times 8 gives you 56, and 4 times 7 gives you 28. So the numerator is addition of pairs followed by the opposite of the value that you want to find. Similar steps that should be applied for RB. If you notice something, the numerator is same for RA, RB and RC, just that the denominator changes. Why? Because the opposite part changes from different place, okay? For the RB, the opposite will be 4 ohms. For RC, the opposite will be 8 ohms. Simple, isn't it? That's all. That's the concept. If you feel confusing, please pause the video, take your time and try to do these questions again and again until you understand, okay? So this is an exercise that I've given, which is to convert from delta to star. Please try it in your own. I've provided the answer. Please check with your solution, okay? That's all from me. If you are benefited, please give me a like, leave comments, and if you have any question, feel free to ask in the comment section. If I can, I will definitely respond to your questions. And please motivate me by giving me a subscribe, and thank you for watching.